Hello, my name is Kelsey Cameron, and today I will be talking about exponential weighted moving averages, specifically in regards to how that is used within TCP and why it is used. So first, I will address this question right here. Why is exponentially weighted moving average used to estimate the round-trip times for TCP? Well, there are several reasons. The first reason is that this average takes into consideration the recent with a higher weight than the past values. So recent values have a higher weight than the past values. Now, what does this mean? This means that as the value is added, it is averaged into the entire round trip time, and the average changes according to what happened most recently, while still taking everything in the past into consideration. So everything in the past has a lower weight, and everything in the every recent round trip time has a higher weight than all of the past stuff, and then they're averaged together. So that's one reason it's used, to take into account recent values with more weight than past values. Second reason it's used, it actually smoothens out the line, kind of like a low-pass filter would do. Smooth out averages. And this is useful because it can help show trend lines. Which is something that might be important to note within a network, because you want to know if your network is getting too congested or if you're not using all of your bandwidth. You always want to use the most bandwidth that you can without wasting any of it, so it's useful to see some of those trend lines. And if you just had a bunch of dots showing data, it might be kind of hard to understand. By having an exponentially weighted moving average, you can see a smoothened out line, and that can help pinpoint the trends a lot better. And then there's so many other reasons that I could mention here, but these are the two main ones. I would say that if I wanted to talk more about the exponentially weighted part, I could talk about the congestion window and how that works, but I think I'm going to save that for the next video. Basically, if a network has problems, if a timeout occurs, the congestion window is set to 1, and then is allowed to increase like double each time. But if there's just a 3 duplicate X scenario, it's just cut in half and then it increases linearly. This is a type of, it's similar to AIMD, additive increase, multiplicative decrease. You may have heard of that. But that's only somewhat related to this, so I'm going to give you an example on how I can actually calculate round trip times in TCP using exponentially moving averages. So I'm going to just get a new page here. So let's see what problem I have. Okay. Suppose the current estimated round-trip time, RTT, for a TCP connection is 50 milliseconds. So current, what's going on? Why did that not write? Something's happening here. I don't know what the problem is. Oh, it's the eraser. That's the problem. Okay. Current is 50 milliseconds. The next 3 acknowledgements come in after 80, 80, and 60 milliseconds respectively. What is the new estimated round trip time? Let the weights for the new acknowledgement be 0.2. So weights for new acknowledgement Okay. So when I say the weight for the new acknowledgement, what does that really mean? Well, it means that I only want to take in to consideration this weight for 20% of it. So that you can think of this too as being 20%. So if I would need 20% to factor in the new acknowledgement, what percent do I need to factor in the old acknowledgement? Well, you only have 100% to work with, so 100 minus 20 is 80%. So the weight for the old acknowledgement would be 80% or 0.8. And this is actually where the 1 minus comes from. The 1 minus comes from percentages. You only have 100% to work with, so if your new is going to be worth 20%, then that means your old has to be worth 80%. And then after this, it becomes a fairly straightforward equation. So my new one is 80, and my old one was 50. So I have 80 here. The new weights, I know I have to give it a weight of 0.2. And the old weights, I have to give it a weight of 0.8 because of the 100% thing that I just talked about. And that's the round trip time average after the first acknowledgement comes in, after the first 80 comes in. This is actually equal to 56 milliseconds. And then, what do? Well, this is my new average. You just do that exact same thing again with the next acknowledgement. The next acknowledgement is 80. So again, 80 times 0.2 plus 56 times 0.8, and if you type that in or figure it out, it's 60.8 milliseconds. And then you use this average for the next one. So you see, I'm actually just substituting it in for the next round trip time, because this is the old round trip time. Every time I get a new acknowledgement, that round trip time changes, and I need to factor that in. So my third acknowledgement is 60 milliseconds, so that's 60 times 0.2 plus 60.8 times 0.8. And when you finish that, you get 60.64 milliseconds. It's a pretty straightforward problem, and it's a pretty straightforward process. Intuitively, it makes sense because the weight for the new one the weight for the new one is given to you, and that means the weight for the old one is 100% minus whatever that percentage is, or 1 minus the decimal, because, 1 would represent 100%, and then the decimal would represent less than 100%, depending on what it is. So hopefully that gives you a little bit more intuition behind it. I've seen a lot of people just memorizing this formula, and it doesn't make sense to me. I don't know why you would memorize a formula when you can just think about it, and it will make sense. So hopefully this clears a few things up, and I hope you enjoyed the video. Have a wonderful day.